this next page, we need to learn the difference between discrete and continuous variables. It's a really important concept to kind of understand domains and ranges. We're going to talk about more detail in a moment, but it says in this first example, the variable x represents the number of friends a person has in their Facebook account. All right, so it's possible that somebody could have 0 friends, they could have 1 friend, they could have 2 friends, they could have 3 friends, they could have 4, they could have 5, but they can't have 2.5 or 2.65. So if you can find 2 distinct values that you're not allowed to use any number in between those, and there's kind of like a gap between those. Like we know of a lot of numbers between 2 and 3, but none of those numbers make sense. So these are considered separated points, which they call discrete data points, because they're separated. They're not all connected. There's gaps between them. The next one, the variable x represents the number of questions a student missed on that test. So you could have 0 questions missed, you could have 1 question missed, you could have 2, 3, 4, 5, and this honestly goes on and on and on. We could continue missing questions, same as this one up here before. But again, you can't miss 1.2 questions. You can't miss 1.678 questions. If we're just talking about number of total questions missed here, again, the data set is discrete because each of the data points are separated, so this is going to be discrete. If you look at the next one, it says the variable x represents the amount of time it takes a student to complete the test. Now you could have somebody take a minute, you could have somebody take a minute and 1.2 minutes, 1.3 minutes, 1.25 minutes. There is no level to which I can't go as far as like decimals. I could keep going. There's always a number between any 2 distinct numbers that would make sense. Like if you said it took somebody 1.2 minutes and somebody else 1.3 minutes, I could say it took somebody else 1.25 minutes, which is between those 2 values. Between 1 and 1.2 and 1.25, there's 1.225. So I can do all the way down to infinitely small, infinitesimally small, and all the values are relevant. I could have any one of these numbers across this number line and it would make sense. So there's no gaps. It's all the numbers are possible for the amount of time it takes a student to complete a test, because time is continuous. There's no gaps. Like in the previous one when it said the number of questions missed, you either missed 1 question or 2 questions, but there's no number, there's a gap between that. You can't miss 1.65. So it's best to see it visually. I think it helps. The variable x represents the height of a student. All right, let's say this is in feet. We could have somebody that's like 6 feet. We could have somebody that's 5.2 feet. Any possible number in between any 2 distinct numbers is still a meaningful value. Like you can have 4.23 feet. And there's any number across this line would be a relevant value for a height of a student. So there's no gaps between them, and that's considered continuous. All right, the next one I purposely left off the values down here at the bottom because it said the variable x represents the value of the money each student has with them in class. Let's do this in cents. Let's just kind of pick up, and I know this goes in both directions forever, so I'm going to put an arrow to the direction this way a little bit too, that it goes at least down to 0 cents. Or maybe I should put it like this. How about like I put down here 0 cents, and then there's a gap between that it could go on. Hang on, let me do that different. That kind of means there's this big gap in the numbers, but let's just say I started at 25 cents. Somebody had a quarter on them. It is possible the next person could have a quarter and a penny, which would give them 26 cents. The next person 27 cents, and again this could go on. You could have all different values of cents that they could have them with. They could have $1.05, which would be 105 cents. But what's important to think about is that somebody has 25 cents and somebody has 26 cents. Those are different values, and there's no number between those 2 that's possible. You can't have 25.5 cents. You can't have 26.8 cents. So it's either you have 26 cents or you have 27 cents. So once again, if there's these gaps or these spaces between values of the variable, then it's considered discrete. Because either you have 25 cents or you have 26 cents. There's no in between. With up here in the previous example, if I asked for the height of a student, if I had somebody that was 3 feet and 4 feet, is there a number between those 2? Sure, 3.5 feet. Is there a number between 3 feet and 3.5 feet? Sure, 3.25 feet. You could literally do that all the way down to infinity, infinitely small, infinitesimal. But with this, I have 2 distinct numbers, 25 cents and 26 cents, and there's no number between those that makes sense for the value of money that a student has. It's either 25 or 26. So this is another example of discrete. The next one, the variable x represents the weight of a package sent at the post office. Let's say this is in pounds. You could have something that's next to 0 pounds. You could have 1 pound. You could have 1.2 pounds. This is another one. Weight is usually considered continuous because, again, if you gave me 1 pound or 2 pound, is there any value between those that makes sense? Sure, 1.5 pounds. Is there another value between 1 and 1.5? 1.25 pounds. Is there a number between 1 and 1.25? Sure, 1.1 pounds. And you can do that all the way down to infinity because any decimal is a possible value for the measurement of the weight of a package, so this one would be considered continuous. Right, the variable x represents the number of packages delivered at the post office on a given day. Alright, so let's just say we had a really slow post office, they had 0 packages. The next number of packages they could have is 1. Again, you can't have 0.25 packages, it's the number of total packages delivered. Again, we have 2, 3, 4, or 5, so if there's gaps between the numbers that make sense, then it's considered discrete. And another key that kind of tips it off as to what it is, a lot of times something that gives away the fact that it's discrete is anytime you see the number of. The number of is usually discrete, because the number of tells you you're like counting, and if it's a counting number or a natural number, then it's definitely discrete. And here x represents the number of packages. It doesn't always work, but it helps with a lot of these. Like the value of the money, it didn't work for, but it worked for the other 3. Alright, so now that you got a visual of it, if there's a gap between them, it's discrete. If it's a solid line, it's continuous. Alright, so now they're asking us, describe the domain and range of each function below as discrete or continuous. Alright, remember x is left and right. So if you look at this for the domain, I'd have a value at -5, -4, but nothing in between those two because they're points. So this would be discrete. And again, the range is the same way. I could have a value at 3 and I can have a value at 2, but there's no value at 2.5. The up and downs, again, that would be discrete. Kind of like you'd expect. It looks very similar to how it was up here. This one, again, left to right, it goes forever left and forever right, and it's a nice, clean, there's no breaks in it, so that would be continuous. Alright, and then again, up and down, it bottoms out at 0, but where it is there, again, there's no gaps, and so it still would be considered continuous. Alright, now this next one's really interesting. It's kind of hard to tell, but definitely if I looked at the up and down, like from -4 is a y value if I'm looking at the range, and the next y value is 1. There's a huge gap vertically, which is the up and down part, so I can definitely say the range is discrete. But I want to show you something interesting that happens with the domain. So I created a visual of this to kind of show it to you. Consider that's roughly the same picture I had on the other side. If you were to like rotate this so it was like laid flat on a sheet of paper, if I kind of rotated that, can you see that how it's like laying down flat? If you lay this down just right flat and look at it from the edge of the paper, you can see that it actually is continuous left to right. Do you see how all those gaps get filled in? I mean, all the blue lines, I know it's kind of hard to see, but that blue line where this one leaves off, this one picks up, and where this one leaves, this one picks up. So in every single one of these places, if it's lined up just right, you can actually see that even though the range is discrete, the domain, the left and right part of it is continuous. It's a solid blue line from left to right. And so basically this one goes over to here and then it hops up to here and this goes over here. So there's no gaps in the domain. The domain is continuous in this one. So it is possible to have a mixture. Not easy, but possible. Alright, so it says find the x and y intercepts of the following functions. Now, to understand what those are, basically, if you think about it, the x-intercept is somewhere where it falls on the x-axis. And the one thing that's true about every value or point on the x-axis is that y is 0. I mean, think about it. X is like right here, that point. That's the point 2, 0. This point right here next to it is the point 3, 0. And the next one's 4, 0. So what I know for sure is if I'm going to find the x-intercept, what I know for certain is that y has to be 0. So when you're looking for the x-intercept, we know that y equals 0. And then all you have to do is plug 0 in for y and solve. That's a little different for a function though, because f of x and y are practically the same. So I want to know when f of x is 0. So what we'll do is we'll set the equation equal to 0 equals 1/2 x plus 6, and then we'll just need to solve for x. So I can do this by subtracting 6 first from both sides, or if we were solving this the way we were on the other, we could eliminate fractions first. Why don't we do that? Why don't we multiply both sides by 2 first to eliminate fractions? So if I multiply that side by 2 and that side by 2, this should make this a little easier to solve. 2 times 0 is 0. 2 times 1/2 is 2 times 1/2 is just 1x, and 2 times 6 is 12. And now to solve for that, all I need to do is move the 12 over. Again, to find the x-intercept, we just set the equation equal to 0, and then I have -12 equals x. So when asked for the x-intercept, the answer is negative 12. Alright, now to find the y-intercept, it's the reverse. You think about every point on the y-axis. Let's kind of flip that around. Think about this point right here. It's the point 0, negative 2. Think about this point right here. It's the point 0, 4. So in every one of these, x is 0, and then the y value takes its place. So on the problem below, if you want to find the y-intercept, that's just where you let x become 0. And it's kind of true. Y equals mx plus b. We've always talked about that b being the y-intercept, but let's go ahead and go through this and do it. So they're basically saying x is 0, so I'm going to let that be f of 0 this time, equals 1/2 times 0, because I replaced that with the x, plus 6. And you can see here that basically f of 0, 1/2 times 0 is 0 plus 6, so f of 0 is equal to 6. And so the y-intercept is 6. So for each of these types of problems, all you need to do is let either let x be 0 or let the equation be equal to 0. So let's start again with the x-intercept first. So for the x-intercept, we let y equal 0, which is basically setting the equation equal to 0. So here I'll say 0 is equal to 3 to the x minus 9. Now I purposely made this one a little bit easier so that we could solve it. So let's start by adding 9 to both sides. And so that says 9 is equal to 3 to the x. Okay, so it's an exponent, so 3 raised up to, you got to think about this, 3 raised up to what power would be equal to 9? So like 3 to the 0 is 1, 3 to the 1 is 3, 3 squared, so let's just write that down really quick. 3 to the 0 is equal to 1, that doesn't work. 3 to the first equals 3. 3 squared means 3 times 3, which is 9. 3 to the third is equal to 27, but I didn't even have to go that far because I found what x needs to be. If x is 2, this one works. So x equals 2 would cause that to be 9. So the x-intercept is 2. Alright, for the y-intercept, you just let x be equal to 0. I know it's kind of maybe counterintuitive. For the y-intercept, you let x be 0, and for the x-intercept, you let y be 0, but that's essentially what we're doing. So in this one, we're going to say g of 0 is equal to 3 raised up to the 0 minus 9. So 3 to the 0 is 1 minus 9, because anything raised to the 0 power is 1, and 1 minus 9 is negative 8. So g of 0 is equal to negative 8, so that means the y-intercept is negative 8. Alright, on this last one over here, it's just basically we're looking at a partial set of values. It says assume h of x is continuous and has a domain of all real numbers. Alright, so they were a little trickier on this one. They didn't give us quite where 0 is, but I think we can look at the pattern and figure out where 0 would be. So if this is going up by 2, up by 2, up by 2, up by 2, if I went down one more value, could you see that 0 would be the next value down if I went down by 2? And look at this value. 6 to 5 is 1, 1, 1, 1. So if I follow that pattern no more, if I go this direction, 2 to 3 to 4 to 5 to 6, what do you think that would be? That would be 7. So here it's just a matter of following the patterns to see what is missing. So I was able to figure out when x is 0, think about what that represents. When x is 0, that's the y-intercept. So the y-intercept is basically when x equals 0. And you can see right here, when x was 0, h of x was 7. So let's write that. So h of 0 is equal to 7 according to that right there. Now going the other direction, 0, 2, 4, 6, 8, 10. It looks like this is getting closer and closer to 0. So the next unit over would have been 1, and the next unit after that would have been 0. And on the top, all that's happening is it's jumping by 2, so this would have been 12, and this would have been 14. Kind of hard to write that. Let me see if I can write that a little cleaner. Sorry, it's just, let me even make this much bigger so I can get over there. It's just right at the edge of my paper. So, alright, so if this is going down 7, 6, 5, 4, 3, 2, I'm trying to get to all the way to 0. So the next point down would be 1, and the next one after that would be 0. And if I follow the x's pattern, it'd be 2, 4, 6, 8, 10, and it's been consistent. The jumps have been consistent, so that would be 12, and that would be 14. So basically here I'm asking for the x-intercept. That's whenever y is equal to 0, which means the same thing in this case as h of x. And you can see right here, that's the point 14, 0. So the x-intercept, according to that table, if it's continuous, would have been 14. All right, I hope this was helpful. Please ask your teacher if you have additional questions.